In this video, we are going to take a look at some of C#'s specialized operators. The first one I'd like to take a look at is the question colon operator, sometimes also known as the ternary operator or even inline if. There are many different names. This particular operator is used to compare a condition. Basically, it's going to return true or false. It can be any logical expression. If it returns true, this operator returns one value. If it's false, then it will return another value. Before we actually use that operator, let's see what this would look like if we were to use, instead of the question colon operator, let's set it up using an if statement. In this particular example, we are going to attempt to divide x by y. We know from previous experience, dividing an integer by 0 is never going to yield a very good result. You get a divide by 0 exception. Well, we're going to divide by 5, but we don't necessarily know what y is going to be. So assuming the user entered y using a console read line and then you parse it, we really need to check to make sure y is not 0 before we do the divide operation. So let's say we test for y not being 0. If it's not 0, we assign to z x divided by y. However, if it is 0, we have a choice here. We can throw an exception, or we can assign something to z that represents a bad value. Like we set it to int.min value. So if we check z later and it equals int.min value, we know something bad happened here in the divide operation. So not a very complicated example, but using the ternary or question colon operator, we can accomplish the same thing in one line. For instance, we could say z equals, and then we're going to copy this condition. If that condition is true, then return whatever follows the question symbol. That would be x divided by y. Otherwise, or the else portion follows the colon, return int.min value as such. This is functionally equivalent to this. Now, this is a little bit odd as far as the syntax is concerned because we have basically three expressions here. We have the one that is the conditional test, and this could be anything that returns a bool, true or false. And then if the result is true, this is the return value of the operator, x divided by y in this case. If this evaluates to false, then whatever follows the colon is going to be the return value. And either one of those then is assigned to z. But again, it's functionally equivalent to this. One thing you may really be seeing at this point is the complexity of the statement. Almost anybody new to programming can follow this if-else block. This ternary operator, however, requires that you have knowledge of this operator to understand how it's going to behave. And it's not always clear how it's going to behave, even if you are familiar with it. For instance, let's come up with another example where we want to constrain a value between two others. So let's create several ints. We'll call this one min value, and we'll set that equal to 0. We'll also create a max value, and we'll set that equal to 100. Then we'll create a value and set that equal to 5. Then we can use a complex set of if statements to make sure that value always falls between min and max value. How would that look? We could say if value is less than min value, then value, since we're constraining it, we'll just make it equal to min value. Else if value is greater than max value, then assign value equals to max value. So regardless of what value is here, it's a 5 right now, the result always has to fall between 0 and 100 based on the logic following. So if it's 5, then it's going to stay 5. However, if it is -5, this will trigger as being true, which will assign value equal to min value. We could also write this very similarly using a series of question colon operators. So in this case, we could say value is equal to, first we check to see if value is less than min value. And if it is, we assign the result to min. Otherwise, we're not done here. We can't just assign value back to it again. What we want to do is do a second condition where we're going to say if value is greater than max, then return max. Otherwise, simply return value. Now, this one will probably make most people scratch their heads when they read this the first time, because we're trying to figure out, is this colon lining up with this question mark? Are they the pair? Or is it this question mark to this colon? Well, it is, in fact, this question mark yields this colon. This question mark is also paired with that colon. What we're saying here is test value for being less than min value, just like we did in the expression here. And if, in fact, value is less than min value, assign min value to value. So that takes care of the true portion of this test. The false portion is yet another test. So this all goes together. It's like we could put all of this in a parenthesis group, and then the false from the first test has its own set of conditions. Then if value is greater than max value, return max value, otherwise return value itself. And that result is then passed as the false for the first test, which then gets assigned to value. So clearly, I'll take out the parentheses because I want you to understand the complexity here. So clearly this is a very powerful operator, but if you use it too much, it can make your code very hard to read, follow, and debug. The next operator I'd like to take a look at is the null coalescing operator. This one is a binary operator that you pass these two values on either side of the operator, and going left to right, whichever one is not null is used as the result of the operator. If we wanted to write this using an if statement, first we'd create a nullable value. It could be a reference type, which can be nullable without any problem, or we can use a nullable int, which I'm going to do here, and we'll assign it null initially. Then we want to, I'm going to utilize value as the result of the operation. We'll say if n equals null, or we could say if n is not equal to null. Let's take that approach first. We'll say value is equal to n dot value. It's one of the simplest ways to get a value out of a nullable type. Else, we need some representation of a bad value, and we'll actually use int.minValue for this. Then, as you can see, if n is null, we will assign to value int.minValue. Otherwise, we assign the value component of the nullable int n. Again, just like the previous example, we have several lines of code, and we're going to consolidate Like in the previous example, we have several lines of code using if statements that we're going to consolidate into a single statement. This time, however, it's probably a little easier to read. We'll say value is equal to n double question, the null coalescing operator, int.minValue. In a nutshell, it is saying value is equal to the first of these, which is not null. If n is null, it assigns int.minValue to value. If n is not null, it simply takes the value of n and assigns it to value as such. This one is very useful, especially if you're reading nullable values out of the database and your object models don't support nullable types. So if you create classes that mimic a database table and the database table allows nullable ints, but your model does not allow nullable ints, then you need some mechanism to check the database values for null before assigning them into your object model properties. In this case, we're just using value. The next operator I'd like to look at is called the null conditional operator, question dot. This one allows us to check a particular object for null prior to accessing any of its members. Let's create a string because it is a very easy reference type to work with. We can assign a null to s as such. Then we're going to create a variable called len, and we want to assign the length of s to len. The problem is if we were to replace this 0 with s.length and we run this code, we are clearly going to run into problems because accessing length will yield a null reference exception. Clearly we have to do something a little more robust. And typically what we'll end up doing is checking for s being equal to null prior to assigning the length as such. But let's define length outside of the if statement so we can utilize it after the if statement's then block is done executing. And then we don't want to do this. We want to say if it's not equal to null actually, then we assign the length. Else, we'll say length is equal to, we need a magic number or some value to represent a bad length or a bad string. We'll just say -1 for this case. So clearly there's a little bit of code involved, and it's following similar patterns to what we used in the previous examples. However, this is the one that's going to safeguard us from accessing these objects and their properties when they could in fact be null, thus preventing null reference exceptions. So what can we do instead? Well, this one we can use the question dot or the null conditional operator by itself or in conjunction with one of the other operators like the null coalescing operator. I'm going to create a new nullable int variable. I'll call this len2, and to it I'm going to assign the length of s. We are not done yet though, because this will still yield a null reference exception if s is null. All I need to do though is change this operator from dot to question dot. Now, if s is null, it will not check the length property. It will simply return null immediately, thus making len2 null as well. If s is not null, then it will actually calculate the length and put that in len2. But right now, we still are probably going to require an if statement to check if len2 equals null before using len2. So we've only passed the buck a little bit. So instead of writing the code as such, what you can do is I'm going to utilize len again, and I'm going to use the same basic operator here, the question dot. Notice here, if I try to use this as such, it's going to complain because it can return a nullable int. But remember, we have this other operator called the null coalescing operator, which allows us then to say if that yields null, let's return another value instead. These are going to be evaluated going left to right. So this is tested first, or calculated first. And if s is null, this entire expression will return null, and therefore it's going to return int.min value. If s is not null, it will then just return the length property of s and assign that to len here. So you can see how the null conditional and the null coalescing operators can work very well hand in hand. We can also call methods as well. Let's create a nullable bool called starts with a, and we'll assign to it the result of calling starts with a. But notice here I didn't say just s dot starts with a. I used the question dot, or null conditional operator, before executing starts with a. This makes sure that s is legal before I start manipulating it by calling this method. Again, we're back to the scenario where we have a nullable bool as the result. We could also do the exact same code, and I'll just copy it. This time I'll call it starts with b, and instead of assigning null to starts with b when s is null, we are going to use the null coalescing operator to indicate that we want to assign false, indicating it does not start with b. So this way I don't have to deal with nulls at all. Before we call the operation starts with, we make sure s is legal and not null. If it is null, we return false. If it's not null, then we return the result of whether or not the string starts with AB. A word of caution about this particular operator: it was reintroduced with C#6. So it's not something that will work in earlier Visual Studio versions before 2015. And you also must be targeting the .NET 4.6 or higher framework. Finally, let's look at this last operator, also known as the safe array indexer. This is very similar to the null conditional operator we looked at before, except this one is going to ensure that an array is not null prior to accessing an element of the array. Let's start with a string array called text. If we wish to assign to this len variable the length of the first string in that array, as such, this will once again yield an exception. Because text is null, there is no way we can access the length member of the first element in that array. So we want to utilize this special operator, the safe array indexer, to ensure that text is not null prior to attempting to access one of its elements. Notice we have a red line, and once again, if this particular operator is null, or it returns null, then we have to be able to accept null as a possible result. Since I already have a len2 variable which is nullable, I can use that one instead. So now if the array is null, it will not attempt to access the first element in the array, and it sure won't access its length property. Running this will go right through. It didn't stop. We don't have a console read line, so the program just ended abruptly. I'll run it again so you can see we have no output on the screen, which is expected since we did not cause any output to occur and we also did not throw an exception. But let's assume that the array itself is not null. We'll set this equal to new string 10. So now we are indicating there are actually 10 elements in this text array. Oh, so this should work just fine now. In fact, it doesn't, because this operator only ensures that the array itself is not null. Once we get past this part of the operation, it is up to us to make sure accessing any of the members is not illegal. Length will always trigger a null reference exception here because we've created an array of strings, but what's the default value for a string? It's null. And since we did not assign any values to these strings, guess what happens? We read the first index value out of the array, that's null, and then we try to calculate its length. So again, the safe array indexer is only used to make sure that the array itself is not null. After that, we have to return to our other friendly operator, the null conditional. This makes sure that once we know we have a legitimate array, let's make sure that we have something we can read out of it. If it's null, again, we get back to the console read line without causing any exceptions, but len2 is null because it passed this test, but then it failed to read an element that's not null out of that position. What happens if we don't want to use this nullable int, len2? Then we get to use one more operator, the null coalescing operator, to return something like int.minValue once again. And now I can take the result and store it in a standard int, because if this returns null, or any of it returns null, we are now going to return int.minValue because we are going left to right. So if this returns null, the whole expression here is going to return null, which means this is going to be the result of the null coalescing. If we get to the length and then we determine, oh, we don't have any elements in the array, so element 0 is going to be null, therefore it can't calculate length, then this operator will end up returning null, which is then going to also cause int.minValue to be the return value. Running this again, we're at the console read line, we pause, and we can see length is in fact equal to int.minValue, which is that -2 billion. So all of these operators work hand in hand, and just like the null conditional, this safe array indexer is only available in C#6 or .NET 4.6, but they all work together to hopefully achieve more robust code. So when you're working with possible null values, these operators can definitely save you a lot of tests using very complex and long if statements.